We're going to do two proofs that you've probably already done yourself in elementary 10th grade or ninth grade geometry, especially in New York City. It's theorem one. If two sides of a triangle are congruent, then the angles opposite the sides are congruent. So here's your given. You're given that the two sides, AB and BC, are congruent. So that's given, you know. That's going to be given. Now we have BC is congruent to AB. Usually, when you want to prove we want to prove that the angles opposite the sides are congruent. So usually you have two triangles to work with. So I'm gonna use the symmetry of the this triangle, isosceles triangle, and flip it over. This is the reflection. This is your shadow triangle. I don't use this, but you may need it. You may like it. Now we have BC is congruent to AB. That's by symmetric property of congruence. The symmetric property of congruence. So we can put these here like this too. Now I'm going to say that angle B is congruent to itself. That's put an X here for reflexive. That's your reflexive property.
Okay, I found this on the web for reflexive property. Check it out.
Shh. Reflexive property of congruence. That was Siri interrupting. Now, I have that triangle ABC is congruent to triangle CBA. That's by SAS. ABC is congruent to CBA by SAS, congruent to SAS. And now angle A is congruent to angle C. That would be CPCT's corresponding parts of congruent triangles are congruent. So it's congruent to its reflection, and that might be surprising. Maybe it's surprising. Now, we want to prove the converse of theorem one. That's theorem two. And theorem two is let's see what theorem two is. Theorem two is if two angles we interchange of a triangle are congruent, then the sides opposite the angles opposite the angles are congruent. So now it really, I need to start again. So I need to make a new diagram, but okay. Now, what we're given is that we're given two angles of a triangle are congruent. So angle A would be congruent to angle C. But angle C is also congruent to angle A. That by the symmetric property of congruence. And now AC is congruent to itself. So triangle ABC is congruent to its reflection, CBA. That would be by ASA, angle, side, angle, angle, side, angle, angle, side, angle. And now we know that, you can put this in, now we know that these sides, these corresponding sides are congruent by CPCTC, corresponding parts of congruent triangles are congruent. There you, that was just a little levity to tickle your funny bone.